In 1967, a mechanic from Daytona Beach rolled a car into inspection at one of the most scrutinized events in American motorsport. The officials walked around it slowly. They pressed metal templates against every panel. They measured the fenders, the roofline, the windshield angle. Everything checked out. The car passed. The same car passed again the following day. What those inspectors couldn't realize, was that they were looking at one of the greatest optical illusions in racing history. The car was a Chevy. It looked exactly like a Chevy. Every curve matched the template. Every measurement they took was correct, but the car sitting in front of them was almost a foot shorter than any other Chevy on the planet. That mechanic was Smokey Yunick. And what he built in his Daytona Beach shop over the course of several months wasn't just a race car. It was a masterpiece of creative engineering, a loophole you could literally drive through, and a story that completely changed how NASCAR writes its rulebook. This is legacy motoring, and I spend way too much time thinking about the moments when one person's creativity rewrites the rules for everyone who comes after. If you're someone who loves the engineering, the drama, and the outright audacity behind motorsport history, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Let's start at the beginning, because to understand what Smokey did in 1967, you need to understand who he was long before he ever set foot in a NASCAR garage. Henry Yunick was born in 1923. He grew up tinkering. The kind of kid who didn't just want to know how things worked, he wanted to know how to make them work better. By the time World War II came around, he was exactly the kind of person the military needed. He became a bomber mechanic in the Pacific, assigned to B-17s. These weren't glamorous postings. These were urgent, brutal, exhausting assignments where the mission never stopped and the parts never arrived on time. Here's what that experience does to a person. When your job is keeping a bomber airworthy between missions and you don't have the right parts, you don't file a maintenance request and wait. You improvise. You adapt. You find a way to make something work using whatever is available because the alternative is available, because the alternative is unacceptable. Smokey spent years in that environment, years of solving problems under pressure with incomplete resources. He came home from the war with a different relationship to rules than most people. Not contempt for rules. That's not quite it. More like a precise understanding of what rules actually are. Rules are written by people trying to anticipate what might happen. They can never fully anticipate what will happen because the people writing them aren't the people solving the problems. There's always a gap between what a rule says and what a rule means. Smokey learned to live in that gap. Back in Daytona Beach, he opened his shop. The sign up front read, "Best damn garage in town." Not a boast, a declaration. He meant it, and the results bore it out. His cars were fast, his drivers won. And NASCAR officials started noticing that the cars coming out of Smokey's shop had a way of being legal on paper while feeling wrong in person. They couldn't always prove it. They certainly couldn't always stop it. Smokey's philosophy was simple and ironclad. If the rulebook didn't specifically prohibit something, it was permitted. Period. This wasn't a technicality he hid behind. It was a genuine engineering ethos. The rulebook is what it says. Not what anyone intended it to say. Not what a reasonable person might assume it implies. What it actually says, word for word. He tested this philosophy constantly. There was the fuel line incident. Officials once found his fuel tank only held 11 gallons when the minimum was 22. They disqualified him. He got in the car, drove it back to his garage. When someone asked how he managed that with half a legal fuel tank, Smokey just smiled. His fuel line was 11 feet long and 2 inches in diameter. That's 11 extra gallons sitting in the line itself. The rulebook specified tank capacity. It said nothing about fuel line dimensions. Legal. By 1966, Smokey had been playing this game with NASCAR for over a decade. He was good at it. He was arguably the best in the world at it. And the world he was playing in was about to change dramatically. The super speedways were evolving. Daytona, Talladega. These tracks were becoming something that nobody had quite planned for. Speeds that had once seemed impossible were becoming routine. And at those speeds, something that most racing teams had never given much thought to suddenly became everything. Aerodynamics. At 30 miles per hour, Air is almost irrelevant. Your engine barely notices it. At 60, you start to feel it. At 100, it's a real factor. But at the speeds these cars were running in the late 1960s north of 170 miles per hour, air resistance wasn't just a factor. It was the dominant force in the race. It determined who won and who finished second. Here's the physics in plain language. Aerodynamic drag increases with the square of velocity. Double your speed and drag doesn't double. It quadruples. At superspeedway speeds, the air pushing back against your car is fighting you with a force that dwarfs almost every other variable in the race. Engine output, tire grip, fuel load, all of it matters less than how efficiently your car cuts through the wind. The factory teams, Ford, Chrysler, understood this. They were throwing enormous resources at the problem. Wind tunnel time, aerospace engineers, computational models, these were not small operations. They were spending hundreds of thousands of $1966 trying to shave a few percentage points off their drag coefficient, hunting for 2 or 3 miles per hour of advantage. Meanwhile, Smokey was in his shop in Daytona Beach, looking at the same physics and asking a different kind of question. What if the car was smaller? Here's the thing about aerodynamic drag that the factory engineers understood but rarely talked about publicly. It doesn't just come from the shape of a car. It comes from the size of the hole that car punches through the air. Frontal area, the total surface your vehicle presents to the wind as it moves forward. Shape is one variable, size is another. And while the factory teams were laser focused on shape, tweaking nose angles, sealing body gaps, optimizing roof lines and wind tunnels, Smokey was thinking about size. A standard 1967 Chevelle presented roughly 22 square feet of frontal area to the wind. That's the hood, the windshield, the roof, the doors, everything the air hits head-on at racing speed. To reduce drag, you either make that surface more slippery, change the shape, or you make it smaller. The factories were working the shape angle hard. Nobody was thinking about the size angle, because why would you? Stock cars were stock. Their dimensions were set in Detroit, fixed by the production line, non-negotiable. Or so everyone assumed. Smokey started doing math. If you could reduce a car's frontal area by 15%, you'd reduce aerodynamic drag by roughly the same margin. At 180 miles per hour, where drag increases with the square velocity, that 15% isn't a minor advantage. It's enormous. The factory teams were spending fortunes in wind tunnels trying to find 2 or 3% improvements. 15% was the kind of number that won races before the green flag even dropped. The question was how. You can't just squeeze a Chevelle. The engine has to fit. The driver has to fit. The suspension geometry has to work. The wheels and tires are fixed sizes. You can't scale those down. And NASCAR had templates. Precisely cut metal forms that inspectors would hold against the body to verify it matched factory specifications. You can't reshape the car, they'll catch it immediately, but here's what nobody at NASCAR had thought through. The templates check shapes, curves, angles at specific points on the body. What they didn't check, what they had no protocol to check, was whether all those points were the correct distance apart from each other. The templates verify proportion. They said nothing about scale. If you built a car where every curve, every angle, every body contour was proportionally identical to a production Chevelle, but the entire vehicle was uniformly smaller, same ratio across every single dimension, what rule would you be breaking? The fender curve would pass the template. The windshield angle would pass. The roofline would pass. Every individual checkpoint would be correct. The car would just be less car. And less car meant less frontal area, less drag, more speed. Smokey landed on a ratio, 7/8. 87.5% of a standard Chevelle in every direction. Not arbitrary, calculated. At that scale, the aerodynamic advantage was significant, roughly 12% less drag at racing speeds. But more importantly, 7/8 sat right at the edge of human perception. Any smaller and something would feel visually wrong. Proportions would start to seem off in a way people couldn't explain but would notice. 7/8 was the precise point where the eye accepts what the brain can't quite process. Small enough to matter, invisible enough to hide. This is where most people stop and assume the hard part was the idea. It wasn't. The idea was elegant. The execution was brutal. You cannot shrink a car by grabbing a saw and cutting. Everything in an automobile is connected to everything else. The frame geometry determines suspension behavior. Suspension behavior determines handling. Every mounting point, every bracket, every angle exists in relationship to every other component. Change one and you change all of them. Smokey started with the frame. He didn't modify a production frame. He built a new one from scratch, shorter and narrower, but maintaining the exact same proportional relationships between every pickup point, every mount, every angle. The geometry was scaled, not simplified. The wheelbase was shorter, but visually the wheels still sat exactly where your eye expected them relative to the fenders, because the fenders were scaled to match. Then came the body. Every single panel, hood, fenders, doors, trunk lid, roof, was hand fabricated from raw sheet metal, not pulled off a production car and modified. Fabricated from zero. Each one had to match the 7/8 ratio exactly, and each one had to relate correctly to every other panel. One piece even slightly off ratio and the proportions would break down. The human eye is remarkably good at detecting when relationships between surfaces are wrong, even when it can't articulate why. The roof required particular problem solving. Scale it down by the same ratio as everything else and the interior becomes unusable. A driver couldn't sit in it at racing height. Smokey lowered the floor pan, adjusted the seat mounting, positioned the driver lower in the chassis. From outside, the roofline looked correct because the proportional relationship between the roof and the rest of the car was maintained. From inside, it was tight. Functional but tight. The glass was its own challenge entirely. Windshields come from factories that produce thousands of identical pieces. You can't call up a supplier and order a custom 7/8 scale windshield without raising serious questions. Smokey sourced it quietly, framing the request in ways that didn't invite scrutiny. The windshield maintained the correct rake angle and curvature relative to the A-pillars. Stand in front of the car and it looked right, because proportionally it was right. Every detail received the same treatment. Door handles, mirrors, trim pieces, sourced or fabricated at the correct ratio. Wheels and tires required careful selection, since those couldn't be scaled, but positioned precisely to maintain the visual relationship between rubber and fender that the brain expects to see. The whole project took months. This was not a shortcut. This was obsessive, precise, painstaking work, measured in fractions of inches across an entire vehicle. When it was finished, Smokey had built something that had never existed before. A full-size race car that wasn't full-size. A car that obeyed every proportion in the rule book while violating the most fundamental assumption behind the entire inspection process. The assumption that a car presented for inspection was actually the size it was supposed to be. Now came the harder part, getting it past the people whose entire job was catching exactly this kind of thing. Bill Gasway had been around NASCAR long enough to develop something inspectors don't talk about openly, but all of them rely on: instinct. The ability to walk around a car and feel when something isn't right before the templates even come out. He caught cheaters with it before, subtle things. A fuel cell hidden behind a false panel. A frame rail that measured correctly at the checkpoints but curved suspiciously in between. An engine that sounded legal but wasn't. When Smokey's Chevelle rolled into inspection, Gasaway felt it immediately. He couldn't name it. That was the problem. He walked the car slowly, running his hands along the body, crouching to check the stance, stepping back to take in the overall shape. Something was pulling at him. That low-level alarm that experienced inspectors learned to trust. But every time he tried to pin it down, the car gave him nothing. He pulled the templates. Hood, perfect match. Front fenders, perfect. Rear quarters, correct. Windshield angle, exactly right. Roofline, matched the spec. He checked the ride height, the wheelbase measurement at the designated points, the wheel well radius. Every single checkpoint came back clean. Other inspectors drifted over, sensing Gasaway's agitation. They started checking things themselves, going back over points he'd already verified, looking for whatever he was sensing. Nothing. The car was immaculate on paper. Here's what was happening and why it worked so perfectly. Human beings are wired to evaluate proportion, not absolute size. When you look at a car, your brain isn't running dimensional calculations. It's checking relationships. Is the hood the right length relative to the roof? Are the wheels the right size relative to the fenders? Does the windshield relate correctly to the A-pillars? These proportional checks happen automatically, beneath conscious thought, and they're extraordinarily sensitive. A car with a hood that's 6 inches too long looks wrong immediately. You feel it before you can explain it. But a car where every single element is scaled down by the same ratio, that just looks like a car. Your brain has no reference point for absolute size in isolation. It only knows relative size. So it runs its proportional checks, finds everything correct, and signs off. The car looks right because relative to itself, it is right. Gazaway's instinct was firing because something was off. But his conscious mind couldn't catch it because the thing that was off wasn't a proportion. It was the entire scale. His brain had never encountered that before. Nobody's had. There was no pattern to recognize, no mental template for cars that is uniformly too small. The alarm was ringing, but the system had no category to file it under. He signed off. He had no choice. Every measurable checkpoint passed. You cannot reject a car because it feels wrong when every number says it's legal. That's not inspection. That's intuition. And intuition doesn't hold up when a team files a protest. But before Smokey walked away, Gazaway stopped him, looked him in the eye, and told him directly, "I know there's something in that car. I can't find it. But it's there." Smokey smiled. That specific smile that everyone who dealt with him remembered. The one that said he was holding information you weren't going to get. He walked away with a legal car. On the track, the Chevelle did what Smokey had calculated it would do. It pulled. Not explosively. This wasn't a power advantage that announced itself on the first lap. It was relentless. On every straightaway, the car was marginally faster than it had any right to be. Not faster in a way that screamed illegal. Faster in a way that made other crew chiefs squint at their stopwatches and check their math. The estimated top speed advantage was somewhere between 5 and 8 miles per hour. In absolute terms, that sounds modest. In context, it's staggering. Teams were spending the equivalent of millions in modern dollars for single-digit percentage improvements. Smokey had found a double-digit aerodynamic gain with geometry and fabrication. No exotic materials, no trick fuel, no engine magic. Just a smaller car. But speed draws attention. In racing, unusually fast cars get unusually close scrutiny. And this is where the story turns. The exact sequence of events that led to NASCAR's discovery varies depending on who's telling it and when. What's consistent across every account is the method. Someone got out a tape measure and started checking overall dimensions rather than template points, and the numbers didn't match. The car was short, not by fractions, by inches, plural, in multiple directions. Once you're measuring overall length against the rulebook's baseline specifications, not template checkpoints but raw dimensional requirements, the gap was unmistakable. This wasn't a manufacturing tolerance. This was a different car. The inspection team dug deeper. And here's where Smokey's approach to rule bending reveals itself fully. Because the 7/8 scale wasn't the only trick in that car. It was the headline. Underneath the headline were other modifications, other gaps Smokey had found in the rulebook's language. The fuel system had its own creative interpretation of capacity specifications. The intake was not entirely what it appeared. The list grew as inspectors worked. Smokey Yunick had not built a car with one loophole. He built a car with several, each one individually defensible, collectively devastating. NASCAR told him the car was being impounded for full disassembly and documentation. This was not a negotiation. This was the sanctioning body exercising its authority over a vehicle that had, at minimum, competed under false pretenses. Smokey's response, depending on which version of the story you hear, was some variation of a shrug and a short sentence. Something like, "If you're keeping it, you should keep it." Then he got in, started the engine, and drove out. Just like that. The impounded, disqualified, now fully illegal race car rolled out of the inspection area under its own power with Smokey at the wheel, heading back to his shop in Daytona Beach. When someone pointed out that inspectors had already removed the fuel tank during the teardown process, Smokey noted calmly that they had not disconnected the fuel line. The line was 11 feet long and 2 inches in diameter. It held enough fuel to drive home on. He'd thought of that too. The story should have ended there. Cheater caught, car impounded, lesson learned. That's how these things are supposed to go. Scandal, punishment, cautionary tale. Instead, something unusual happened. The racing community heard what Smokey had done and responded not with outrage, but with something closer to admiration. This requires some context to understand properly. NASCAR in the 1960s was not the corporate, sponsor-driven, television package sport it would eventually become. It was rougher than that, closer to its roots. The men who built those early racing machines came from a world where rules were obstacles and creativity was survival. Many of the foundational figures in the sport had literal experience, running from law enforcement, moonshine runners who discovered that the skills required to outrun a revenue agent on a mountain road translated surprisingly well to oval track racing. The culture they created valued ingenuity, respected audacity, had a specific kind of reverence for someone who could outthink the system rather than simply outspend it. In that culture, what Smokey did wasn't shameful. It was exemplary. He had read the rulebook completely, understood it more thoroughly than the people enforcing it, identified a gap they hadn't considered, and executed a solution with such precision that it passed scrutiny twice. The fact that he eventually got caught didn't diminish that. The fact that he drove home on fuel that existed in a line they'd forgotten to disconnect, that was the part people kept repeating in garages across the South for decades. NASCAR's institutional response was exactly what you'd expect. They rewrote the rules. They added specifications that hadn't existed before. They created inspection protocols designed to catch exactly what Smokey had done, and anything adjacent to it. Overall dimensional requirements became explicit. Measurement procedures became more comprehensive. The rulebook that had been navigable in an afternoon became significantly denser. This pattern, innovation, exploitation, codification, is one of the most consistent rhythms in the history of motorsport. Someone finds a gap, they exploit it. The governing body closes it. The rulebook gets thicker. Repeat. Smokey's contribution to this cycle was unusually large because his gap was unusually fundamental. He hadn't found a technicality in a subsection. He'd found an assumption so basic that nobody had thought to state it explicitly, that a car presented for inspection would be the size it was supposed to be. Once you see that assumption, you can't unsee it. NASCAR couldn't unsee it either, so they stated it explicitly, measured it thoroughly, and moved on. But here's what's worth sitting with for a moment. The rulebook changes in response to what Smokey did are still visible today. Modern NASCAR inspection involves three-dimensional laser scanning technology that compares every surface of a car to a perfect digital template, accurate to thousandths of an inch. The entire system, the comprehensiveness, the precision, the paranoia about dimensions that were once considered self-evident, traces a direct line back to a guy in Daytona Beach who asked what would happen if he made the car smaller. The 7 and 8 Chevelle is why NASCAR checks things nobody used to think needed checking. Now zoom out from the specific story and look at the broader pattern it represents, because this is where Smokey's legacy gets genuinely interesting. Every major racing series in history has had its version of Smokey Yunick. Not a cheat in the crude sense, not someone hiding extra fuel in secret compartments or swapping illegal engines in the dark. Something more sophisticated. Someone who understands the rules well enough to operate in the space between what they prohibit and what they permit. Someone who reads the rulebook not as a list of boundaries, but as a map of possibilities. Formula One in the late 1970s and early 1980s produced several of them. Colin Chabon at Lotus pioneered ground effect aerodynamics, using the underside of the car to generate downforce in ways the regulations hadn't anticipated and couldn't initially address. The rules said nothing about it because nobody had imagined it. By the time the FIA caught up, Chapman had already moved on to the next idea the rules hadn't considered yet. Ferrari, McLaren, Brabham, every team with serious engineering resources was playing the same game, finding the spaces between the words. The Brabham BT46B, the fan car, ran exactly one race before being withdrawn. It used a large fan ostensibly for cooling purposes that happened to also evacuate air from under the car at a rate that generated extraordinary downforce. Technically legal, politically untenable. Gone after one appearance. Sound familiar? In endurance racing, the Porsche 917 and subsequent prototypes repeatedly pushed at the boundaries of what aerodynamic regulations permitted, finding interpretations of the rules that the authors hadn't intended but couldn't specifically prohibit. The turbocharged era in Formula One produced engines that operated in qualifying trim at power levels the regulations hadn't been written to contain. The methodology is always the same. Read what the rule says, not what it means to say. Find the gap between intention and language. Build something that exploits that gap with maximum precision. The Smokey Yunick approach, applied across 60 years of motorsport development. What's changed is the cost of entry. In Smokey's era, a genius with good fabrication skills and a willingness to think differently could walk into a major race with a car that rewrote the competitive equation overnight. The tools required were a shop, some metal, and a mind that worked differently than everyone else's. The resource gap between an independent builder and a factory team was large but bridgeable by creativity. Today, that gap is unbridgeable. The computational fluid dynamic systems that Formula One teams run require infrastructure that costs more than Smokey's entire career earnings. The data acquisition systems on a modern NASCAR Cup car process more information per lap than existed in the entire sport in 1967. The inspection technology, those laser scanners, those digital templates, catches deviations that no human eye could detect. What this means, practically, is that the creative space Smokey operated in has been compressed almost to nothing. The rulebook has been written and rewritten by people who have specifically studied what happens when you give creative engineers undefined space. They've learned, they fill the space with language. So the question isn't whether modern racing has its Smokey Yunicks. It does. Every serious engineering team and every major series has people whose job is explicitly to find what the rules don't prohibit and build something that exploits it. The question is whether those people operate with the same freedom, the same potential for singular creative disruption that Smokey had in 1967. Almost certainly not, and something about that is worth acknowledging honestly. There's a version of this story that treats Smokey Yunick as a cautionary tale. The cheater who got caught. The guy who pushed too far and paid for it. NASCAR tells a version of that story every time they point to their modern inspection protocols as evidence of how seriously they take competitive integrity. The laser scanners, the digital templates, the zero-tolerance dimensional checks, all of it framed as progress, as the sport cleaning itself up. That framing isn't wrong exactly, but it's incomplete in ways that matter. What gets lost in the cautionary tale version is what Smokey was actually doing beneath the rule bending. Because the 7-Section 8 Chevelle wasn't just a cheat. It was a genuinely sophisticated piece of engineering that demonstrated something the sports establishment hadn't considered. That aerodynamic efficiency at superspeedway speeds was potentially more important than raw horsepower. That a lighter, smaller, more slippery car could defeat a more powerful one if the physics were right. That the competitive equation had a dimension nobody was optimizing for. Smokey proved that. Illegally, yes, but he proved it. And proving things, even illegally, advances understanding. Within a few years of the 7-8 Chevelle incident, aerodynamics became the central arms race in American oval racing. Factory teams that had been focused primarily on engine development started pouring resources into body design. The superspeedway packages that NASCAR teams run today, the low-drag, high-downforce configurations that require entirely different setups than short tracks, exist in part because Smokey Yunick drove a slightly smaller car through an inspection process that wasn't equipped to catch it. He was right about the physics before the sport was ready to admit it. This happens more often than the official histories tend to acknowledge. The person who breaks the rules to prove something is often the person who understood the underlying reality before anyone else did. The Wright brothers flew before the aviation establishment believed flight was possible. Barry Marshall infected himself with H. pylori bacteria to prove that ulcers were caused by bacteria rather than stress, because no ethics board would approve a proper study of an idea the medical consensus considered absurd. Ignaz Semmelweis told doctors to wash their hands decades before germ theory gave them a framework to understand why, and was institutionalized for his trouble. The pattern is consistent. Someone sees something real. The institutions around them don't have the framework to evaluate it yet, and the only way to prove it is to do something the institutions consider improper. Sometimes the proof is accepted. Sometimes the person is remembered as a troublemaker first and a pioneer second. Sometimes both. Smokey Yunick is remembered as both. In racing circles, he occupies a specific kind of legendary status that's different from the respect given to championship-winning crew chiefs or successful team owners. It's the status given to someone who changed the way everyone else thinks about the problem. Not just solved it, reframed it. The specific innovations in the 17th Chevelle are long since banned and irrelevant. The templates it fooled had been replaced by technology that would catch it in seconds. But the thinking behind it, the insistence on reading what the rules actually say rather than what everyone assumes they mean, the willingness to operate in the space between intention and language, the application of genuine engineering creativity to the problem of competitive advantage, that thinking is still the most valuable thing a race team can cultivate. Every crew chief who has ever found a legal advantage in a gray area of the regulations is working from the same fundamental playbook Smokey wrote. The specific pages have changed. The approach hasn't. Now here's what most people don't realize when they hear this story for the first time. The 7-8 Chevelle was not Smokey's most significant technical contribution to motorsport. It's his most famous story, but fame and significance don't always align. Over his career, Smokey Yunick held more than 50 patents on automotive innovations. His work on engine efficiency, heat transfer, fuel systems, and chassis dynamics produced ideas that migrated from racing into production vehicles and influenced automotive engineering broadly. He wrote a technical column for Popular Science for years. He corresponded with engineers at NASA. He consulted for automobile manufacturers who needed someone who thought about mechanical problems differently than their internal teams did. The man who built an illegally small race car was also the man who genuinely advanced the state of automotive knowledge in ways that had nothing to do with bending rules. This is the fuller picture that the cheater narrative tends to flatten. Smokey wasn't creative because he wanted to cheat. He was creative because creativity was how he engaged with every problem. The rule bending was an expression of the same mindset that produced legitimate innovations. You can't have one without the other. The brain that looks at a rulebook and sees gaps is the same brain that looks at an engineering problem and sees solutions nobody else has tried. He passed away in 2001. The tributes that came from across the motorsport world, from NASCAR officials who'd spent decades trying to catch him, from factory engineers who competed against him, from drivers who'd raced in his cars, all of them said roughly the same thing in different words, that he was the most original mechanical thinker any of them had encountered. That being around him changed how you saw problems, that the sport was categorically different because he'd been part of it. Bill Gazaway, the inspector who signed off on the 7-8 Chevelle despite his instincts screaming otherwise, talked about that moment for the rest of his career. He said it was the one that stayed with him. Not because he was embarrassed by it. He'd done his job correctly, given the tools and protocols available to him. It stayed with him because of what it revealed, that the inspection process was only as good as the assumptions behind it. That expertise creates blind spots as surely as it creates capability. That someone sufficiently creative and sufficiently knowledgeable could construct a reality your mental framework wasn't built to process. He was looking directly at the answer. The whole car was the answer, and he couldn't see it. There's something in that worth carrying beyond racing. Every system of evaluation, every inspection process, every audit procedure, every performance review, every regulatory framework is built on assumptions about what it needs to check for. Those assumptions reflect the knowledge and imagination of the people who design the system. They check for what they've seen before, what they've been warned about, what falls within the range of things they can conceive of someone trying. The gap is always what they haven't conceived of yet. The gap is where Smokey lived. The 7-8 Chevelle never won a championship. It ran, it dominated briefly, it got caught, it drove home on fuel sitting in an oversized line. Its racing career was short and its legal status was zero. By conventional measures of success in motorsport, it was a failure. But 60 years later, people are still talking about it. Still telling the story in garages and paddocks and YouTube videos with varying degrees of accuracy about the names and the measurements. Still using it as shorthand for a certain kind of thinking, lateral, precise, audacious, committed to the logic of the rulebook rather than the spirit of it. The car became a legend not just by getting caught, but almost because of it. Getting caught meant the story had an ending. It meant the scale of what Smokey had done became visible to everyone, not just the people in his shop who'd watched it get built. The inspection, the discovery, the impound order, the drive home, all of it gave the story shape, gave it drama. Turned a clever engineering solution into something people could retell across generations. So the next time you're looking at a system, any system, not just racing, and you find yourself wondering whether the rules actually say what everyone assumes they say, you're doing exactly what Smokey Yunick did in that Daytona Beach shop in 1966. You're reading the map instead of following the crowd. Most people find the rules and stop there. A few read them carefully enough to find where they end. Smokey didn't just find where the rules ended. He built something there, drove it to Daytona, passed inspection. And when they finally caught him, he drove home on the fuel nobody thought to drain. That's not cheating, that's reading comprehension at a level most people never reach. If this kind of story is what you come here for, subscribe. We find the moments where one person's thinking changed everything, and we tell them the way they deserve to be told. Drop in the comments, what system have you encountered where the rules didn't quite say what everyone assumed? We read every one.